Alrighty, hi there. In this video, I'm going to do just the stat key from section 3.4. I was going to tack it on to the end, but then I realized that could make the video a little too long, so I decided to do a separate video. So here's the PowerPoints over here, and here's StatKey that I have opened up. So I'm just starting it at the same place that we left off the stat key in section 3.3, which is the ants on a sandwich data set. So here's your ants on the sandwich, right? So we already saw how to type that in and stuff in the previous section. So when we did ants on a sandwich, it was sample statistic plus or minus 2 times the standard error here. We're going to do it a little bit differently now. So when you do the sample statistic plus or minus 2 times the standard error, I could probably make this a little bigger. There we go. Yeah, when you do the formula, now this is bell-shaped and symmetric, so it's fine, but it's not an exact confidence interval. So the way you get an exact confidence interval, so the instructions are here, right? So you click two-tail, right? And then this is your confidence level, so it defaults to 95% confidence. So that's the default setting, right? If you want to do a different confidence level, so we could stop here, right? And this is the one that's in the notes, we have a 95%. But we could stop here if we want. But if you want to do a 99%, you just click here, change it to 0.99. Your confidence interval gets wider. If you want a narrower interval, you know, 0.90. And you can type in any number there you want. So that's how we do it. And StatKey just counts dots for us. So it's up to you how many dots. StatKey doesn't care how many dots you use. I'm just showing you how I generated the graphs in the notes. For a lot of the homework problems, you know, if we reset it, if you want to do like 10,000 samples, just keep clicking this thing, it's fine. You can click it as many times as you want. You tend to get like a better bell-shaped distribution, so when you click two-tail, you know, it's a little more accurate, but usually 1,000 samples is totally fine. As far as I know, that works for all the homework problems. All right, the other problem here was talking about who smokes more. Okay, so let's talk about how I generated this graph in StatKey. So the instructions are not given here, but it's the same thing from this. What you have to understand, though, is when you do these, you log into StatKey, and the first thing you have to do is decide, what are the variables? How many variables, categorical or quantitative? All that stuff must be done before, because some of these data sets are built in, some of them are not. All of the quantitative data sets are built in, but the categorical ones are easy to type in. So when you're doing the problem, you know, here we can see it's p hat m minus p hat f. That tells us two categorical. So we do a bootstrap confidence interval. So this is a difference in proportions, right? Now again, it's up to you how you come at this thing. If it's easier to start over here and say it's two categorical variables, it's in the same row. Whatever works for you, do it, because every problem's different. Every problem gives you a different amount of information, different kinds of information. But don't guess, because on a test you have to know what to select. So it's difference in proportions. Now some of the data sets are built in, right? Smoke by gender is built in, so I'm just going to click it. If you have to edit the data, just type in what you need. And I'm going to generate 1,000 samples, so let's go here. So you can see it looks pretty similar to what I have here. It's never going to look exactly the same, right? You can click reset and just keep generating new graphs. It's going to look a little bit different every time you do it, just because it's randomly generated. But you'll see the standard error is pretty close. Here, let me make this a little bigger, just so you can see that all the numbers are going to be pretty similar. But you have some margin of error on the homework. So here, see, the standard error is what we're really interested in here, because the center of the distribution is centered at the original sample statistic anyway, right? So here, the center of the distribution is 0.045, right? So there you go. So that's how you do it. And then if you want to do your confidence interval, just click two-tail, and then you change this to any numbers you want. So from there, it's the same. Oop, what did I do there? I did something wrong. Oh, there you go, 0.9, 90% confidence interval. There you go. Alrighty, so that's basically how you do the StatKey for this. There is one other thing I wanted to show you. I'll show you how to type this in too if you're not sure how to do it. So if we're doing males minus females, it would, so here's your sample statistic, just 27 out of 193, just because some of the homework problems you do have to type it in for the categorical stuff. And when you do that, so let's just focus on the StatKey here. So over here, it gives you your original sample statistic there. It just says group 1 minus group 2, but you have to know that this is your sample statistic, p hat 1 minus p hat 2. So when it says group 1 minus group 2, it's talking about the proportion, okay? And it just computes it for you. So when you generate 1,000 samples, let's say, well, actually, let me do a little. Let's generate one sample. Let's see what's going on here. So I'll show you how this works. I already explained how to do a bootstrap distribution for a single mean and a single proportion. Let's look how to do it for difference in proportions. You'll see it's real similar to what we saw before. So here is a single sample. So here's our bootstrap sample. It shows up down here. And you can see that in group 1 in our original sample, it was 27 out of 193. In our bootstrap sample, group 1 is 19 out of 193. So how does that happen? Well, this is actually the same as the rats problem we did in a previous video, where you would just have 193 pieces of paper and 27 of them have X's. And you reach into a hat with all of these pieces of paper and you pull one out. If it has an X, you record X. If it doesn't, you just leave it alone. Put it back in, mix it up, pull out another piece of paper. And just record what percent, how many X's out of the 193. So if the original sample had 27 out of 193 in the bag and you mix it up and you pull them out, 193 of them, one at a time with replacement, 19 of them in this sample had X's. Well, you do the same thing for group 2. There's 169 in group 2, 16 of them have X's. After random sampling, it was 12 out of 169. So what we're doing here is using the original sample to generate the same amount of variability, and then the center of the distribution is centered at the original sample statistic, and that's how we do it. And you can see that if you generate, 1,000 samples, so if we go all the way to the right over here, because if you mouse over these, you can see that the bootstrap samples change. You can see all the numbers move around. Let's look at this one here. So the bootstrap sample all the way on the right, you can see that started out 27 out of 193, but sampling with replacement became 40 out of 193. Group 2 started out 16 out of 169, after bootstrap sampling 8 out of 169. Right? So you can see that there's a lot of variability, and that's why this distribution is so wide. And we can go all the way over here to the left side. So let's look at one of these way on the left. In this one, we actually had more females smoke in this group, right? You can see this is 19 out of 193, so 0.098 proportion of male smoke, whereas after sampling with replacement, 26 out of 169 female smoke, which is 0.154, and that's why you get negative numbers. So that's why you get negative numbers and positive numbers. So using the original sample, there's a lot of variability, and that variability causes uncertainty, and the uncertainty causes the width of the confidence interval. So there you go. So that's how this works. For the other two parameters that we didn't go over, it's similar to this. If you have a difference in means, it's just names. It's like doing what we did for the ants on a sandwich. You'd put all the numbers in a hat for one group, pull them out, take a mean, the same way we did for ants on a sandwich. Take the other group, put all the numbers in a hat, mix them up, pull them out, average it, and then subtract the means. And correlations are also similar. So Not going into all those details, or this video would be super duper long, but the idea is that there's always some kind of sampling with replacement that goes on. So bootstrapping, no matter which of the 5 parameters you're looking at, when you do this repeated sampling with replacement, it always kind of manifests itself the same way. All right, well, that's it, how to do this stuff in StatKey. So if you're worried about this at all, go back through the PowerPoint and just follow along and click on everything and make sure you can get graphs that look like these graphs. And you should be good to go. All right, well, that's it for this video. See you next time. Bye-bye now.